Hey financial modeling guys, so this short video is going to cover regressions. So what I'm going to explain how to derive the coefficients of regressions, and I'm not going to talk about the underlying assumptions too much because people don't care about that much, you know, when they're doing it in the industry. So I'm just going to do it, and then we'll talk in class more about hypothesis testing and all that, and then I'll do a video about it. So what is a regression? So regression is actually a very simple thing. You have two variables, y and x, and what you want to do, you want to get a linear presentation of y through x. So you assume that you have a linear function, okay? But as in the world, these are random variables, so linear functions are not exact. And what you have here, right, you have the alpha, which is the intercept. You have the beta, which is the slope. Right? And then you have this guy, which is the residue, which is basically the error, okay, between the real values of y and this kind of representation. Okay. So first, why do we want something like this? So we have, in risk management, we have two reasons why we want this. So first of all, right, we want to predict. So say you're a trader, right, and you have the market, for example, okay? You have the market X, and then you have a stock Y, and you have some feeling what the market is going to do, right? You are a trader, and that's your job. And let's say that you're saying that X is going to move to X1, right? So what will happen with Y? Okay, so it's not only directionally, right, but you want to have some sort of a model of seeing what happens with Y. So if you have X, of course, right, it's actually very easy to see what happens with Y. With Y, you will just say, okay, I have Y0, which is going to be alpha plus beta X1, X0 plus epsilon, right? So it's basically a prediction. Second thing, right, which is very important, and it's basically sensitivity. And this is prevalent in risk management, right? So basically what happens in risk management, that you have some factors, let's say you have a factor X, right? And you have a stock Y. And what you want to do, you want to get a feeling of what happens with, when X moves, what happens with Y, okay? So it's kind of a, you know, sensitivity thing, right? So here you can actually see what happens, right? If X moves by certain amount, then the Y will move by beta times a certain amount, right? In a way, or almost exact, right? The beta is actually the derivative of Y versus X if we ignore the random variable. If we ignore the random variable, but you know, philosophically speaking, okay, we have that beta equals basically the sensitivity of Y versus X. Okay, so if Y and X are, let's say, two series of returns, right, and you kind of know information about X, you know exactly what will happen with Y, right? Now, the epsilon, right, the residue, is assumed like that it is going to be independent, okay, of your X. So it's going to be orthogonal, right? We talked about the fact that covariance, you know, that if you have two variables called X and Y, the covariance of X and Y, okay, is basically going to be, you know, some sort of a scalar product. It is a definition of scalar product. So everything that we did in linear algebra pours into the statistics, into this risk management realm, okay? So the fact that covariance of epsilon and X, right, are equal 0, right, means, it precisely means, okay, that what you are getting here is orthogonality. So basically, if X is like this, epsilon is like this, and if X moves, you have no idea what will happen with epsilon. So you have no prediction power, right, on the residue. So the maximum prediction, so this beta, right, satisfies kind of the quote-unquote the maximum prediction power, right? So we can speak about, you know, minimal, you know, I did this in class, the minimal norm condition, but you know, in philosophy, for me, I'm thinking about this in a much better way, that beta is epsilon as S, that X, that you have this kind of thing. So if X moves, you have no idea what happens with epsilon, right? So from that, we can actually derive the formulas for beta and alpha, right? So first let's first derive the formula for beta, okay, so we know that covariance of epsilon x equals 0. It means, right, what it means is that y minus alpha minus beta x with covariance of x equals 0. Okay? Now, you're getting from this, right, once you know that, first of all, you can write this as covariance of y x minus covariance of alpha x minus covariance of beta xx times beta, and this equals to 0. Okay. Now, here, observe that this guy is 0. Right? Why is it 0? Because alpha is a constant. So e of xy minus e of x times e of y is a definition of covariance, right? This is your covariance. This is cov. But now you can see that if y is a constant, you will have e to the x alpha minus ex times e alpha. And because this is a constant, you will get that this is 0, right? Because e of x alpha equals to ex times alpha. Okay? So this is good. So from that, you are going to get, of course, that beta, okay, equals to covariance of xy divided by the covariance of xx. Okay? So you have a formula for beta. Now, how do you get a formula for alpha? Well, this is easy peasy. All you need to do is to assume that the average, the expected value of y, right, is actually is actually in this part and not in the epsilon, right? So basically what you assume that expected value of y minus alpha minus beta x, right, equals 0. And from that you get, of course, right, that this is the expected value of y minus alpha minus beta e to the x, right? So from here you immediately get that alpha equals to the expected value of y minus beta, the expected value of x. Okay? Now, it is important to understand that whatever we did here, right, whatever this model is, has, it is true for every distribution. So if you are going to assume two random variables, okay, and you are going to assume a representation like that, and you want to demand that epsilon x equals 0, right, and that everything and the average of y is consumed by this part and not by this part, these are the formulas you are going to get. Now, where's the trick? Why is it so good, in finance and risk management? Well, in finance and risk management, okay, we assume, right, that we are in a normal world, that everything is distributed normally, right? So x, y, epsilon, and of course epsilon will be distributed normally because you have epsilon is just a difference between two normal distributions. Okay? So when you assume something like that, remember, okay, it's a key fact that normal distributions have only two parameters that fix them. It's a alpha, it's a mu, which is expected value, right? And, right, it's a sigma, which is the standard deviation. And if you have a multi-dimensional normal distribution, okay, independence of two variables, right, if they are jointly normally distributed, joint normal, and they're independent if and only if the covariance is equals to 0. Right? So here, okay, you have a much stronger statement. If we're in the normal realm, right, and we assume jointly in normal distribution and all this stuff, okay, this epsilon will be actually independent of x, right? We said in class, and we gave a couple of counterexamples, that if you have random variables, you can have covariances equal 0, right? But it doesn't need to be independent, okay? And here, okay, because you have this kink of normality, right? You see that covariance of epsilon, okay, x equals 0 means that x and epsilon are independent. So you're getting something, much stronger for free, okay? So this is basically the, the setup for regressions. What you need to remember is those formulas, this covariance of xy divided by covariance of xx, and what you need to remember is the formula for alpha. So what we're going to do in class, right, we're going to talk about hypothesis testing. We're going to talk about how to use this in order to test, for coefficient p-values and whatnot, and, confidence intervals. So we will do a couple of videos about that later, but for now, right, this video just to explain you how you can operate those formulas, okay? So great, thank you very much, and this is like somewhat of a tough part, a lot of people don't understand it, so I hope that this video makes it easier for you, okay? So that's it, and have a great day, and I'll see you in class. Thank you, and bye.